Hello everyone, to this video we're going to go do some testing on undervolting on a desktop Z490 Vision D motherboard. We are now setting the baseline for the power consumption and the score for Cinebench R23, and this is with the BIOS settings at voltage defaults, and so we're getting 129 watts as package power and almost 13,900 points. So I will now open Throttlestop, and I will also let the CPU cool down. This cooler is a bit broken. This machine was brought in because the customer dropped it, and probably the cooler got somehow screwed. It unscrewed itself. It was like running very noisy. I now just proceeded to screw it back quickly, and I will then proceed to actually swap it probably because it's not performing as good as it should. It's 98 degrees now. So the first thing that we are gonna do is we're going to set 95 offset voltage, which was the offset voltage that I was having set in the BIOS on this machine. So this machine was running at -95 in the BIOS, and with the -95 in the BIOS I was getting 114 watts, and the score was the same, basically the same for R23. So let's see. First thing first, let's see if we get the same reading by doing the undervolt on Throttlestop. And the first interesting thing that we're going to notice is that we are actually getting I would say 10 watts less with the Throttlestop undervolt compared to the BIOS undervolt, which is kind of weird to begin with. I also have to say that this machine used to be stable at -110, but then I had to drop it to -100 actually after some testing, which was kind of strange, but that's maybe another topic for another video. Maybe it was like just silicon quality degrading, or I don't know. The machine was heavily used, like the guy was mixing and mastering basically every day. So the score improved slightly, and our power consumption, yeah, I forgot to reset the counter, but it was 101 watt, 102 watts, which is way lower than what we got with the BIOS. So let's get in the BIOS, set the offset undervolt to -100, sorry, -95, just the same as the Throttlestop, and run the test again. Let's see. Okay, we're in the BIOS. Now this is a Gigabyte motherboard, so the Gigabyte motherboard has a very weird way to like start with -300, so you have to go through a lot of numbers to actually input the right one. That's how I do it. So I was at 95. The VCCIR and system agent are already tuned for the memory that we're running. This memory is some stock like JDEC. I don't really know the actual chipset that are in, but this is already tuned. And yeah, so the first thing that I want to note is that probably with this undervolt on the Throttlestop settings, I would probably be unstable, because I was getting like again, like I would say like 12 watts less than what I got with the BIOS undervolt. So now we're 95 offset on the BIOS, and we will check again with R23 our power readings. I also have the machine hooked to power meter down there to double check the results. So let's see. Let's get the test started. We are now reading 112, 113, which is going to rise as the test goes on, because as the test goes on, the temperature increases, and with the temperature increase, you get higher power consumption. So we're running from the wall 146 watts, and it's getting pretty stable. I don't think it's, no, it's not, of course it's not throttling. We're now doing much better. We are 20 watts less than the stock configuration, but we are 12 to 13 watts higher than Throttlestop is. So again, the funny thing is that actually this machine became unstable on boot with a minus 100 offset. Yeah, because I'm trying to recall the story of this machine. Oh, the score is also slightly higher, which is weird. Like, again, with an margin of error. So let's do one other thing. Let's now open Throttlestop and see what happens, because we now have the offset already working in the BIOS, and I wonder what's going to happen here. So we're now running this minus 60 on the CPU. Keep in mind here, this was the peak power consumption during the test with the undervolt coming from the motherboard. But now we're gonna see what happens if we actually like do a mixed undervolt. We're gonna add 60 and see if this value of 60 actually overrides the 95 on the BIOS or doubles down and gets like, should be 155. Let's see. So it seems that we're actually adding up to the undervolt, but in a weird way. What I mean is that previously we had minus 95 on Throttlestop, and it was reading 101 watts. Now that we have 60, which should be adding up to a total of 155 undervolt, we're getting 109. So the thing is that nothing, all this doesn't make much sense, but we're having an improvement. This is actually an improvement. We are now ending the test. The test is coming to an end, and the power consumption is lower than the peak that we measured, and it's also lower here. You can see it's 4 watts less. So it's actually consistent with the reading from hardware info. So it doesn't make 100% sense, but it does make some. So I already did a lot of these tests, but I'm just doubling down everything. What happens then if we shoot like this? The thing is, the system doesn't crash, okay? And let's see the result if we start the test. Oh, I didn't let it cool down as much as the other times, so we're starting from a higher temperature. And what is happening is that we have almost the same power consumption as we had with minus 60. So I don't know really actually what to think about this. It doesn't make sense again, not that much. It seems that it's not reading minus 200. Maybe there's some kind of fail-safe mechanism that is engaged, and so the system doesn't read minus 200. Let's try to read 85. And nothing changed. So maybe what is happening here is that it only read our first undervolt offset and then ignores everything else that we set afterwards. Very weird. You see, we are having kind of like a slightly higher power consumption, and that's because our temperature is higher, because we started from a higher temperature in the beginning. I will now show you something which is interesting, and that is, I mean, maybe it's not going to happen this time, but if I try to set like minus 12 offset on the cache, I do get some kind of result. And then if I set like something like 25 to 30, it's gonna crash. Here you see, it's like 2 watts lower already. And if I set this to like, oh, I don't know actually what's gonna happen here. Oh, because I used to set like 35 as the first value, but now, okay, nothing makes sense anymore again. Okay, it did hang. Now so this is doing something for sure. And another thing that is clear, and that is coming from a lot of other experience with a lot of notebooks, where I only use Throttlestop to test the machine and Windows, is that we always have a much higher undervolt on the core than we have on the cache. Okay, so this is like this is kind of like a lucky one on the cache, because this is 180 on the CPU, 210 on the GPU, and 130 on the cache. And this is actually a kind of good cache undervolt. I'm testing the cache undervolt with a memory test from OCCT, which is kind of good at getting cache errors. And this 130, but we had a lot of times where this value was 180, which is kind of average for 8th generation Intel CPUs. This is a 4-core 8 threads i5. But the CPU cache would stay at minus 100, minus 90, 95. So it's, on average, I would say that the cache goes a little bit higher than half of the CPU core. So now with the machine hang up completely, I will reboot. Power supply is 400 watts. Be quiet, gold. I am going to set minus 110, which I think was the value that I set with this BIOS when I first delivered the machine, and it would cause random problems at boot after a couple of, like, 2 years maybe. Like 1 year ago it started having issues, one and a half. So now it actually, okay, here it is. So it's boot looping, as you can see, with 110, which was fine when I first delivered the machine. Kind of probably silicon quality, something like that. It shows the boot screen and then reboots. Sometimes it gets to actually finish the boot. I would say maybe 105 would be fine. You can see the boot loop. So I now have to spam cans, and it will actually go to the BIOS if I wait enough. Kind of interesting, right? There it is. We're now in the BIOS. I will set 100. And so what's next? Okay, 100 booted up fine. Oh yeah, so what's next is that we're going to test. Oh, this is remembering minus 12. I have to set like 95, because the issue we had is that apparently it was only applying the first offset that we input. Like that could have been. So I'm trying to recall. It was 101, the lower that we got with the offset from Throttlestop. So let's start R23 again, and let's see. Whoa, we're now reading, 107, 108. So it doesn't change that much. So again, it does make some sense, because with the offset from the BIOS alone, we were getting 114. And if we add up the Throttlestop offset, we lose another 4 to 5 watts. But the offset from Throttlestop alone was giving us better results. So what's next? Well, what's next is now we're going to try to see what happens if we only set the offset from Throttlestop and we set maybe something like 140, which I would guess on 120 maybe would be like the absolute limit for this kind of CPU, which is a 10900 engineering sample, which is like running similar to there's no real mobile equivalent for this, but it's a 10 core that is boosting at 4.1 gigahertz, as you can see here. So it's similar to a mobile, what a mobile 10 core would be. So let's go on with the test. We'll now go back to the BIOS and try to take out the whole of undervolt from the BIOS and do a mixed undervolt with different values on Throttlestop and see if that gives us the best undervolt result. I will now have to also test the stability of that undervolt, but that comes afterwards. So what we'll do here, let's see. Oh, come on. Okay, that's it. Okay, we're in, and I will start with, yeah, -20 was actually registered. So this is the first value that the machine is going to see, and let's check what happens. We should see something like around less than 100 watts now. It could hang. Not sure. Oh, interesting. Oh, well, that's because we don't have any cache undervolting. So the cache is actually playing a huge role here. So let's undervolt the cache. Let's set it to -100. Here it is, 97 watts. It all lines up perfectly. Yeah. Let's see what we're reading from the wall. 137. So yeah, Throttlestop is doing more undervolt than the BIOS for sure. And the whole undervolt here is actually working because we had 101 before. And now we have 98. And that's because we are at -120, well previously we were at -100. So this is also, I don't know, maybe gonna help actually with the stability, because we're not applying the BIOS undervolts, so we're not getting stuck at the boot loop, and maybe we can actually set a higher, like a better undervolt when we're in the system. This is gonna require extensive testing for stability, but it's kind of interesting. And I guess that's enough questions and a couple of small answers. And so if you really want to get the best out of your undervolt, you should definitely consider doing it by software, because you can get a much lower voltages on the CPU offset than the one you can get from the cache. And so it is actually better to work with the Throttlestop, or of course, as I do Hackintosh, I work with the Voltageshift. And so thanks again to everyone for watching. Thanks, huge thanks to the creator of Throttlestop. He's my hero. And also the creators of Voltageshift for Hackintosh, for macOS. And ciao a tutti!